Boom. Well, let's try it again. There we go. Boom. That's better. All right. How many questions have we got to do? 37. All right. My goal is to get through all this today. I'm going to take an hour today. So we'll be done around 2 o'clock. If I don't finish today, then we'll pick it up tomorrow. And we'll go until we're done. My hope is that I'll be at least halfway through, if not pretty close to done, by the end of today. If you have questions as I go through this, then feel free to post them to me wherever is most convenient for you. I'll try and keep an eye on as many places as possible if people are sending me questions as I do this. Remember, if you miss something, then you can go back. Let me just make sure your audio is working. Yep. Okay. And make sure my writing is okay. Test. And hopefully that shows up and now goes away. Ba-ba-ba-ba-da-bum. Okay. All right, I'm going to go ahead and get started. We're starting with Pythagorean Theorem. That's our first review kind of topic here. Find a missing side of each triangle. Leave your answers in simplest radical form. So that is our Pythagorean Theorem. C squared equals A squared plus B squared. And so remember that C is our longest side in the triangle. The hypotenuse that's opposite the right angle. So if we're looking at the right angle, we look across from it and we see our hypotenuse. That's C. So 11 squared equals the square root of 26 squared plus x squared. That's the part we don't know. So now we're going to do 121. That's 11 squared. The square root of 26 squared. Remember that square root and square undo each other. So the square root of 26 squared is just 26. It's exactly 26. Plus x squared. So we're going to subtract from both sides. Ooh, man. There we go. Nailed it. 95 equals x squared. So we're going to take square root of both sides. And let's make sure that, because it asks for simplest radical form, means we need to see if the square root can be simplified. 95, we're going to divide it by 5. That's 19. And that's only divisible by 19. So we've hit our top of the tower. No pairs. No pairs means we leave it as square root of 95. So that's Pythagorean theorem, remembering that hypotenuse is our longest side across from the right angle. This jumps around a little bit as far as order goes. Next. Determine if the measures form sides of the triangle, then state if the three sides form an acute, obtuse, or right triangle. So, first off, we need to figure out what our longest side is. Well, we have 5 times the square root of 7. And even without the calculator, I know that 5 times the square root of 7, let's see, that is between 2 and 3. Right, because square root of 9 is 3, square root of 4 is 2. So, square root of 4 is less than the square root of 7, which is less than the square root of 9. So that means that we're between 2 and 3. So we have 5 times something between 2 and 3. Well, 5 times 2 is 10, and 5 times 3 is 15. So 5 square root of 7 has to be between 10 and 15. Well, that's less than 16, so 16 is my longest side. And what we're going to do, just so that we remember, I'll keep this as C. First off, if we add up 9 and 5 square root of 7, we're going to get something bigger than 16. 9 and something between 10 and 15, that's bigger than 16, so we have a triangle. So 9 plus 5 square root of 7. The two shortest sides have to be bigger than the longest side. Check. Alright, so we have a triangle, we just need to figure out what kind of triangle. What we're going to do is we're going to check c squared on one side, and we're going to check a squared plus b squared on the other side. And we're going to see which one's bigger. That's our process on this one. C squared, we have 16 squared equals, or not equals. We're trying to see if it equals. And then we'll make this a and b. We have 5 square root of 7 squared plus 9 squared. (16 squared is 256. 9 squared is 81. 5 squared is 7 squared. Remember that this means we're going to square 5, and then we're going to square the square root of 7. So we got 5 squared, which is 25, times the square root of 7 squared is 7. So really this is 25 times 7, which is 175. If you're putting it in your calculator, so if I go over to the calculator, then we're going to have 5. Sorry. We're going to put parentheses. That's the important part. We got 5 square root of 7. I'm going to hit the arrow because I'm done with the square root. On some calculators, you close your parentheses at that point. But we want to make sure we close parentheses so that we're done with 5 square root of 7. We want to take all of that and square it. And hey, 175. So 175 plus 81, that's 256. Hey, they're equal. So that means I have a right triangle. Because c squared is equal to a squared plus b squared. If c squared were less, then it would be acute. If c squared were bigger, then it would be right. next. And if you're just joining and you missed going through something, then remember that you can always go back and watch it again. And I'll have this posted later today as well. All right, find the missing side lengths. I tried to make these ones pretty easy. These are my 45. This is a 45, 45, 90, 45, 90, and here's a 30, 60, 90. 30, not 36, 30, 60, 90. Can't write today. So over on the 45, 45, 90, this is, the idea is that our side lengths are the same. And then our hypotenuse is whatever that side length, the length of the leg was, times the square root of 2. That was our pattern for 45, 45, 90. Okay. Since those angles are the same, then the sides across from them are the same. So we got 5, this is 5, then this is 5. And then this is going to be 5 times the square root of 2. Done. It's just establishing that pattern. If you want to do trig and set up tangent and cosine to confirm this, then you can. But you're going to get the same thing. You should get something equivalent to 5 and 5 square root of 2. And then our pattern for 30, 60, 90 is that we have our short leg. And then we have our hypotenuse, which is double the short leg. So this is my double side, was the way I put it sometimes. And then we have our short leg times the square root of 3. Oh, well, if this is my double side, then y, which is the original, if I doubled to get 10, that means I must have started with 5. And then that means x is our short leg, which is 5, times the square root of 3. Again, done. All right, I said you'd feel deprived of your geometry experience if you didn't get ladder leading against a wall. And so, one more time for good measure. 24-foot ladder rests against the side of a house. Here, let's draw a little house. This is a tall house. Those are windows. Here's a door. Roof. There we go. It's about as detailed as I get here. The idea is that we got this right triangle right here. So this is my ladder, so that's 24 feet. And we're saying that the point is 7 feet from the house. So this distance from the ladder, bottom of the ladder to the house is 7 feet. And then the top of the ladder is resting against the house is y feet above the ground. Y. So this is another Pythagorean Theorem question where we're going to say that here's my hypotenuse. So this is my hypotenuse. So we have 24 squared equals 7 squared plus y squared. And so what we're doing here is we're just using Pythagorean Theorem to solve for the part we don't know. If you got a right triangle and you know two sides and are trying to figure out the third, then you'll want to use Pythagorean Theorem. This is 576. So we can solve this here. So, sorry. Start that over. Start that over. Oh, not that far over. Okay, 576 equals 49 plus y squared. So we'll subtract 49 from both sides. That's better. So we got y squared to be 527. So we just need to take square root of that. It says to go to one decimal place this time, so that's to the nearest tenth. So we'll take the square root of that answer. Oh, we get 22.95. 22.95. So that means when we round, it's going to be 22.95 is going to round up to 23.0 feet. I'm putting 0.0 so you know that that's not exact. That's rounding to the nearest tenth. Okay. Let's keep going. Find the value of each trigonometric ratio. Where can I write this? Let's write it over here. We have SOHCAHTOA. This is our trig, so we want SOHCAHTOA. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. So if we want cosine, cosine is going to be adjacent over hypotenuse, which, let's see, that's of angle C. Well, then, if we want the cosine of angle C, then we're going to have our adjacent, which is 10. Adjacent's the one that's touching, the leg that's touching the angle, over the hypotenuse, which is across from the right angle, that's 26. Longest side across from the right angle. 10 over 26, which reduces to 5 over 13. That's all you need to do on that one. These next problems will be solving an equation. So 10 over 26, which reduces to 5 over 13. All right. Next. Here we are. Find the measure. So we're going to do a bit of trig here. We're going to actually solve some equations this time. We're going to go sides. Whoa. Back up. What happened? First off, I'm losing bits of my SOHCAHTOA as I go here. There we go. All right. Just like we did on the homework and on the tests, I'm going to go, my sides are going to go to the nearest tenth, and my angles are going to go to the nearest degree. and or the nearest whole number. Okay. So we're going to start by figuring out which trig ratio you're going to use. So I'll give you about 1 minute, and I want you to think about, while I grab some water, I want you to think about what trig ratio should you use on each of these. Right, before we go through, we'll go through and solve every one in detail. So just glance at each of them and see if you can figure out on each one what we're going to use. All right, let's see if you figured each of them out. Here we are told the hypotenuse, and we want to solve for opposite. Opposite and hypotenuse, that's going to be sine. Sine of the angle, which is 67, equals our opposite, which is x, over the hypotenuse, which is 20. So multiply by 20 on both sides. To get rid of the fraction, multiply by whatever's on the bottom. So we had x to equal 20 times the sine of 67. So remember, there's no division happening here. So when we go to put it in the calculator, we're just going to put 20 sine of 67. Actually, let's check that we're in degree mode first. Mode degree, good. 20 times the sine of 67. Should close my parentheses, but we're fine. 18.4. Next one, we should be using tangent. Because we know opposite, we're trying to find adjacent. Opposite and adjacent, that's tangent. So tangent of my angle equals, we have opposite over adjacent. Opposite is 13 over adjacent, which is x, which is the one we're trying to solve for. So we're going to multiply by whatever's on the bottom to get rid of the fraction. And we have x tangent of 36 equals 13. So now we're going to have division when we solve this, because we have to x times a tangent of 36. Remember, tangent of 36 is just a number. So we have x times some number equals 13. So we're just going to divide by it. So we have x to equal 13 over tangent of 36. 13 over tangent of 36. So we're going to go ahead and put that in the calculator. We got 13 divided by tangent of 36. Close parentheses. 17.89, so to the nearest tenth, we're going to round that to 17.9. And finally, this one we're going to use cosine of our angle, because we know adjacent and we're trying to find hypotenuse. Adjacent and hypotenuse, that's cosine. Equals adjacent, which is 11, goes on top, over hypotenuse on the bottom. And so we'll solve that the same way we just solved that one. We're going to multiply by what's on the bottom to get rid of the fraction. Cosine of 17 is just a number, so we're going to divide by it on both sides. So we get x to be 11 over cosine of 17, which will round. I'm going to do it in my calculator over here. That should round to 11.5. Remember, make sure you're dividing. It's 11 divided by cosine of 17. Now we're going to shift gears, and I'm going to, we're going to do inverse trig now. Inverse trig. Okay, the only difference is that instead of using the angle to solve for a side, using the angle to solve for a side that we don't know, now we're using the sides. We're going to be using the sides to solve for an angle we don't know. But the way that we're going to choose our trig ratio is basically the same. Let's see, we have opposite here and hypotenuse. That's what we know in terms of the angle we're trying to find. So opposite and hypotenuse, that's sine. Sine of my angle is what I don't know. Equals opposite, which is 47, over the hypotenuse, which is 55. And so this is where we're going to use inverse trig. And the only thing that inverse trig does is that it just lets us rewrite it so that we can solve for the angle. All right, we're just rewriting it so that I can put it in my calculator. That's all we're doing. Nothing fancy with the equation solving. It's just another way to rewrite it so that your calculator can spit out the answer for you. So let's have the calculator do that. To get to your trig, to get to sine, we're going to hit second. Well, let me do this. There we go. To get to sine, you're going to hit second sine. That's your sine inverse. And then we had 47 over 55, I believe. Let me double check that. Yes, but let's type in 47 instead of 57. 47 out of 55. Close parentheses. Equals. And that's my angle. 58.7, and we're going to round that to the nearest degree. So x to be approximately 58.7, which we're going to round. We're going to round to 59 degrees. Rounding up since we're rounding to the nearest whole number. Over here on 11, we know adjacent and we know hypotenuse. So if we know adjacent and hypotenuse, then to solve for this angle, we're going to use cosine for adjacent and hypotenuse. Cosine of my angle, I don't know it, equals adjacent, which is 31, over hypotenuse, which is 43. So again, all we're doing here is we're rewriting it so that we can put it in the calculator. Cosine inverse of that ratio. approximately second cosine, then 31 over 43. Close parentheses. 43.8, so we're going to round it up to 44. And finally, on this last one, as you might be able to guess, we're going to use tangent. And we're going to use tangent because we know opposite and we know adjacent. So opposite and adjacent, that's tangent. Tangent of the angle, we don't know it, equals opposite, which is 14, over adjacent, which is 15. And so we're going to rewrite it so that we can put it in the calculator. Tangent inverse of 14 over 15. And I'll put this one in my calculator here. Tangent inverse of 14 over 15. Again, it's second tangent. And you should get 43.02, so we're going to round that to 43 degrees. There it is. So that is most of my trig. We're at about the halfway point on the stream for today. And so I'm going to take a quick 2-minute break. Again, we are going to we're going to get through as much of this as possible today. Whatever we don't get through today, we're going to do tomorrow. And if you watch these streams and follow along with me, then you're going to be done. Again, if you have questions coming in, then feel free to send them to me on here, on Remind, on Canvas, whichever, wherever. Area, yes, yes. Okay. We're ready. Now, normally these would be formulas that I would be expecting you to memorize. So hopefully you know at least a couple of these. So let's look. Area of a rectangle is length times width or base times height, however you prefer it. So our base here is 5.5 times our height, which is 3.9. $21.45. meters squared, since it's an area. Area of a triangle, that's a triangle. So area of the triangle is 1/2 base times height. My expectation is that you would know these first two and then kind of be struggling to come up with the last one. This is a rectangle. I know it's a rectangle because all four angles are the same. This is a triangle. I know that because it's got 3 sides. There you go. Area equals 1/2 our base, which is 6, times my height, which is dropped down perpendicular to the base. That's 1.9. And so if we put that in our calculator, we're going to get 5.7. Again, meters squared. Next, this is a trapezoid. In the area formula, I like to describe it as average of the bases times the height. And so my height is my distance that connects the two bases. Average of the bases times the height. So we're going to have 9 as my height times average of the bases. So we have base 1 plus base 2. So my bases are 9.4 and 3.8. And we're going to cut that in half. So that equals 9 times, well, let's see. This is 13.2. Cut that in half, and we're going to get 6.6. So we have 9 times 6.6, which is 59.4. Again, meters squared, since it's an area. Next, where are we? Oh, I want to jump down to 25 real quick. Before I do this page, I'm going to jump down to 25 real quick. How much do we have? Okay. Good. So I have an idea of about where we'll stop. We'll do, I want to do the regular excuse me. I want to do the regular polygon. And then I want to do the surface area and volume stuff, and then we'll stop for today, and we'll finish the rest tomorrow. Tomorrow should be a shorter stream. It shouldn't take as long. That'll take us pretty well past halfway done. So, area of a regular polygon. I just put one of these on here, and we'll go through it together. So area equals 1/2 ASN. So we'll look for, here's our apothem, side length, number of sides. This is what we started the remote learning with. These are the first set of notes that we did from home here. So remember, the steps are, we're going to write out the information that we know. For example, we know this is, let's see, 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. Since it has 6 sides, that means n is 6. Our number of sides is 6, and our side length, this is our side length, is 10. So this side is also 10. And then remember what we did was we drew this triangle from the center, and we drew it out and dropped down a height and this was my apothem. So let me just draw that over here really quickly. And our idea is that we're going to use trig to solve for this apothem. Whole side length is 10, means that each of these is 5 and 5. And what we did was we found our central angle. So I'm going to separate this out here. Central angle was 360 divided by a number of sides. And that's because all the way around is 360 degrees. And so this angle, to find this angle, well, there would be 6 of these triangles. So we're going to divide by 6. There's a triangle for each side. So that's why we're dividing by number of sides. And there we get 60. So we're going to cut that in half to get 30. So this is 30. If you know your 30, 60, 90 pattern, then you'll know that this is that this will be 5 square root of 3. In fact, we had one where the short leg was 5 and that this was 5 square root of 3. If you don't know that, then you can always use your trig. So we're going to use tangent, since we know opposite and don't know adjacent. Tangent of 30 equaling 5 over our opposite, which is 5, over our adjacent, which we don't know yet. So we're going to multiply to get rid of the fraction. I'm going to go through this quickly because we did a bunch of trig up earlier. And so we have a times a number, so we're going to divide by that number. $8.66. And if you put 5 square root of 3 in the calculator, you'll find that it's going to be the exact same number. Okay, but I'm going to go ahead and use 5 square root of 3 in my formula here. So the area is 1/2 my apothem, which is 5 square root of 3, times your side length, which is 10, times the number of sides, which is 6. And so that's going to turn out to be something that will round to 259.8. 259.8. And our units should be squared since it's an area. Next, let's move on to surface area and volume. That was a while ago. Hopefully you're more familiar with surface area and volume. More comfortable with it. Here we go. Starting with surface area. Remember, surface area, I talked about surface area as well, we're covering the surface. So if I were to design a label for this container, how much space would I have along the outside? That's a surface area question. All right. Whoa. Here we go. Surface area equals we have twice the area of the base plus perimeter of the base times the height. That's for a prism. This is a pentagonal prism. All right, so let's start with area of the base. Area of the base, well, this is a pentagon, so we're going to use 1/2 ASN. Now, luckily, we know our apothem and we know our side length. Our apothem is this height down here. It's 4.8. Times your side length, which is 7. Times the number of sides. It's a pentagon, so it's got 5 sides. Put that all in. Oh, it's 84. 84. And usually we kind of divided this into base area and lateral area, so let's do that. Lateral area was perimeter of the base times the height. And perimeter was, well, we add up all the sides. The sides are 7 and 7, and there's 5 of them. Which equals 35. I'm cutting into my sphere here. Hope it doesn't mind. Our height here is our distance that connects the two bases. So what connects the bottom base to the top base? Well, it would be this distance right here. That's 12. So perimeter times the height is 35 times 12. Times 6, 420, I think. So then when we go to our surface area formula, then it's easier to plug in here. Surface area equals twice area of the base plus perimeter of the base times height. So twice our area of the base we found was 84. And then our perimeter times the height we found was this up here. So we're going to transfer it right down. So our final answer, let's see, 168, so 588 meters squared. Surface area is still an area, so meters squared. We might only get through surface area. Let's see. We will see. Okay, I cut it into the sphere. Again, if I'm going too fast, you can back up the stream. You should be able to rewind it. So don't forget that. So if you need me to go back and look at something, then feel free to do that. If we have a sphere, then our surface area of a sphere is actually nice and easy. It is 4 pi r squared. So, unlike the last one, which was really complicated, only thing we really need to know here is the radius. That's the only thing we don't know, is our radius. So our radius, remember, distance from the center out to a side, so that is right here. 11.7 is my radius. And so our exact answer, 4 times 11.7 squared, our exact answer would be 547.56 pi. If we ask for an exact answer in terms of pi, there's our answer. Now, if we want a rounded answer, if we want an answer like it asks for rounded to the nearest tenth, then we would do 547.56, and then we're going to go times pi to get our rounded answer. 1720.21. And since we're going to the nearest thousandth. Oh, hold on. To the nearest thousandth. So 3 decimal places. 2104. So 210. I didn't look at the 4th decimal place. Usually we've been going to the nearest 10th. 210. Inches squared. Surface area is still an area. So our sphere is a lot more straightforward. Next. This is a, well, since all these sides are the same, that makes this a square pyramid. Square pyramid. So our surface area formula is just area of the base, since there's only one base, plus, since these other surfaces are triangles, 1/2 perimeter times our slant height. Remember, our slant height is our distance scaling up the pyramid, as opposed to our height, which would be straight from the center up. So this is our height. This would be our slant height, which is what we're actually interested in. Area of the base. Well, area of the base is just side squared, since it's a square. So that equals 10 squared, which is 100. So 100 is our area of the base. 1/2 the perimeter times our slant height. This is what's called our lateral area. It's the area of all these triangles put together. Perimeter. Add up all the sides. They're all 10. 10 and 10 and 10 and 10. Boom, 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 boom. So that's 40. Our slant height is our distance down here up to the top. So our slant height is going to be 12.1. So in total, 1/2 our perimeter times our slant height is going to be 1/2. The perimeter here is 40 times our slant height, which is 12.1. 12.1. There we go. And that equals 242. So to get our surface area, we'll just add them together. We got 100, and then 1/2 PL, that is 242. So add those together, and we get 342 inches squared, since it's still an area. I'm going to jump down and do the cone before I erase this, because our cone, the good news about our cone is that it basically uses the same surface area formula. Area of the base plus 1/2, but instead of perimeter, when we're looking at a circle, instead of perimeter, the word we use is circumference, and that's our only difference. So the cone formula is the same as the pyramid formula, except instead of instead of perimeter, we use circumference. So we're going to do the same thing. We're going to divide it down. We're going to split it up. Area of the base. Well, area of the base, that's a circle, so our area is pi r squared. So that is pi times our radius. Oh, careful, careful. Our radius here is from the center out to the side. So if all the way across is 14, then halfway across should be 7 squared. So that equals 49 pi. That's our area of the base. And then we have 1/2 the circumference times the slant height. Our circumference, formula for circumference is 2 pi times the radius. Our radius here is 7. So we get 14 pi. And then our slant height. Oh man, I meant to use a different color. That's okay. Our slant height here is scaling up to the bottom of the cone this time. 15.7. So 1/2 the circumference times our slant height should be 1/2. Our circumference is 14 pi. And then our slant height is 15.7. And we'll get 109.9 pi. So then, to get our surface area, all we have to do is add these together. Area of the base is 49 pi plus our other piece of this is 109.9 pi. 109.9 pi. So our exact answer would be 158.9 pi. But if we're rounding it to 3 decimal places, 158.9 and then pi will come out to be, let's see, 498.5707. So we're going to round that to, again, 498.5707. So we're going to round it up to 1. Meters squared. Again, surface area, still an area. All right, one more, and then we'll stop for today and finish the rest tomorrow. Tomorrow we'll have volume to do, which is actually simpler than surface area. Surface area is a complicated one. We'll have volume to do, and then we'll do some stuff with similarity and circles that we have done. So stuff from the very beginning of the semester and the very end of the semester tied together here. All right, but let's clear this off and talk about this cylinder. Now, the surface area of a cylinder, just like cone is related to pyramid, the surface area for a cylinder is related to the prism. Twice the area of the base, plus, not perimeter. Instead of perimeter, we're using circumference. Times the height. We don't have a slant height this time. So instead of perimeter, when we talk about circles, we're talking about circumference. So again, we're going to divide this up. Area of the base is pi times the radius squared. So our radius here, careful, it's the distance from the center out to a side. So if the entire thing is 12, then halfway across would be 6 squared. 6 squared is 36 pi. That's our area of the base. And then circumference times the height. Circumference times the height. We want circumference is 2 pi times the radius. So 2 pi times 6, that's 12 pi. And then our height connects the bases together. Connects this bottom circle with the top circle. That's 11. So circumference times our height would be, we have 12 pi times 11. So that equals 132 pi. Now, in the prisms and cylinders, the formula is a little bit more complicated when we go to plug it in, because we got to do twice the area of the base and then plus this part. Twice the area of the base, so twice 36 pi, plus our circumference times the height. That just goes in. Like always, it's 132 pi. There we go. So we put those together. Let's see, that should be 204 pi. And so if we want to round it, that's going to go to 3 decimal places. 204 pi that's going to be, let's see, 640.8849. So let's round that. 640.8849. So we're going to round that up to 885 meters squared, since surface area is still an area. All right. That's going to do it for me today. We'll finish this up same time tomorrow, 1 o'clock. And we'll finish up the rest of this. If you missed any of it, there's still going to be an archive of this. As soon as I'm done, you can watch it all back as soon as it's done processing. And so we should be able to finish this up pretty easily tomorrow. It probably won't take the full hour. And then you'll be done. That's going to be all I'll have for you. So look forward to that. As always, I hope you're taking care of yourself. And I will talk to you more tomorrow. Take care.